So one thing I want you to go back and fill in, I forgot about this, is yes, this is the width of my rectangles, but in order to get it, remember we did the width of the interval, which was b minus a, that's the whole width, and we divided by how many rectangles we were doing. So we're going to need that because we're going to do a quick review on the sums, and then we'll practice again tomorrow on these of the rectangle areas. So since I'm going to start by finding the area using 5 subintervals and doing the right endpoints, I'll first need to figure out what delta x is. So now remember delta x is b minus a, and there's my interval, so I would be doing 6 minus 1 over n, and remember n is the number of rectangles, so that would be my number of subintervals. So in this case, I'd be dividing by 5. So delta x is 1. And then I also need to know what x sub I is. And remember, x sub I is nothing more than a, which is 1, plus delta x, which is 1, times I. And then I have to find f of x sub I. And if I go back up here and look at my function that I want to be plugging in, I'm really doing f of 1 plus I, and that's going to give me the square root of 1 plus I minus 2. And so now I'm ready to do right endpoints. And remember the formula for right endpoints is the summation of I equals 1 to n. I want to go all the way to the last marker for the right endpoints. And then I have to do 1 plus I minus 2. There's the height of my rectangles. Remember, that's my f of x sub I, times delta x, but delta x was just 1. And so now I have to simplify this out and use my formulas for I. What I would recommend, because a problem like this is going to appear on the calculator, is that you remember how to put this into your calculator. And so if you remember back to doing sequence, we were looking at sequence and then the formula. So in this case now, your hamsters don't use the variable I, they use x. So we would be doing 1 plus x. Ooh, I got a little crazy there on the width of the radical. And then minus 2. There's that's my whole formula after I multiply by 1. And then the variable that I'm evaluating or that I'm changing, or just who the variable is in the formula, which is x. And then the beginning, which was 1. And when I say the beginning, I'm talking about here. So I'm going from 1 to 5, and I'm counting by 1. And so if you put that into your calculator, and actually you can even bypass that, and let's just say, since we're doing sigma, let's put sum in front of all this. So we'll put that in an extra set of parentheses, sum. And then your hamsters will actually do that all for you, which is good because I get a decimal value of negative 0.168. Okay, so I'm going to repeat this process, but this time I'm doing left endpoints. And if you remember on the left endpoints, we went from, Oh, I might have written that wrong on the last page. I think I did. Go back and turn left endpoints. This was supposed to start at 0. We're starting at the 0th position and going to the n minus 1. Now we know that our n is 5, so we'd be going from 0 to 4. So go back and fix that. I'm almost positive that I wrote that as a 1 on left endpoints back on the previous page. So please, please, please go back and change it. Okay, so now I want to, again, do f of x sub I times delta x. So this formula doesn't change. The only thing that changes is the boundaries. So I was doing the square root of 1 plus x minus 2 times 1, because that was delta x. And so again, I can put this into the hamsters. As a matter of fact, I don't really need to change much because I'm still doing the same sequence, the same formula. Minus 2, make sure that minus 2 is outside of the radical. The only difference now is that I'm going from 0 to 4, counting each rectangle by 1s. And so when I put this into my calculator, this time I get negative 1.618. So now, keep in mind what the graph actually looks like. If I were to graph the square root of x minus 2, it would look like this. Just kidding. It would look like this. So I do have, in fact, some of this that's below the x-axis, which is why I'm going to end up, and if I'm looking from 1 to 6, okay, so now I actually graphed it so that the graph was correct. It actually passes through 4, 0, so you can see that I have a lot of area that's underneath the curve. And certainly, if I start from the left endpoint, as opposed to starting from the right, remember for the right, I would actually have used this. So the right ones all would have been under. And now the left ones, when I draw in the left ones, so the left one would look like this. And you can see that it's going to be quite a bit over. So that's why the value got bigger. So there's more negative area. Remember, negative because it's underneath the x-axis. Okay, so now I'm going to move on to midpoints. So going back to how I actually calculate the area using the midpoints, remember this is the width of my rectangle still, and then I have to find the y values for each of the midpoints. So now the midpoints, remember I was going from 1 to 6, and so normally I'd be counting, x equals 1. If I were doing left points, x equals 1, x equals 2, x equals 3, x equals 4, x equals 5. Those would be the left x values versus the right x values would have been x equals 2, x equals 3, x equals 4, x equals 5, and x equals 6. So I'm looking for what's in the middle of them. So in the middle of them, I'm looking at x equals 3 halves, x equals 5 halves, x equals 7 halves, x equals 9 halves, and x equals 11 halves. Those are the values that would live in between every right and left x value. And so you could just add those together and divide by 2 if that doesn't make sense to you. Okay, so now I've got to find, those are my x, I should actually have labeled these perhaps for you, the midpoint. So midpoint 1, and midpoint 2, and midpoint 3, and midpoint 4, and midpoint 5. And so now I've got to find the y value for each of those, except again, I can use my calculator to do those calculations. So now I have to look at what the formula looks like. I notice every single one of those midpoints is over 2. And I notice that it starts, the pattern is that it starts at 3 and it goes to 11. And every single time that pattern increases by 2. So when I put it in, I'm going to put x over 2. Again, the variable is x. I want x to start at 3. I want it to end at 11. And I want it to count by 2s. And so the way that I do it in order to get the hamsters to do the calculations is I put this sequence into list 1 in my stat editor. We used this one time before to try this when we were messing around with these earlier. And then I go to list 2 and I want to take the square root of all those midpoints and subtract 2. Remember, that's how I find my y value. So I would do square root of these numbers I just created in list 1 minus 2, because this is how I get the y values. This is my y formula. And I'd let the hamsters do all the calculations for that. And then I'd go back to the main screen and I would find the sum of L2. And since this sum, going all the way back up here to the beginning, so this sum would now be this, and I'm supposed to multiply it by delta x, that sum. But remember, delta x was 1, so it would be sufficient to just look at whatever the sum is. And when I do that, hopefully you were able to follow along, I get negative 0.857, which is not surprising because that number is between the answers for right endpoints, which was the negative 0.1, so let's see, this was right endpoints, was negative 0.168, and the left endpoints was the negative 1.618, and of course this answer lives in between them, which is what I would expect. Remember, this is back to the Goldilocks, and your right and left endpoints, one of them will be too big, the other will be too small, but the midpoint formula is kind of just right.